Welcome to my talk about Micro-Frontends and Me. And I'm here today standing in front of you to talk about something very dear to me, something that I care very, very much about, and that is birds. Everyone likes birds, right? There's supposed to be over 11,000 species of birds on the planet, in all kinds of sizes and colors, capable of incredible feats. And each bird on its own seems insignificant, but by and large is a part of a very large complex ecosystem. And complex systems are hard. Then why do us, as engineers, love to make a system even more complex? Why do we love complexity? In the 1960s, we put a man on the moon using a computer less powerful than what you have in your pocket right now. The architecture was pretty simple. We had one mainframe, multiple terminals, you type in commands, the mainframe processed them, and send the results back. All the data, all the logic, everything happened in one place. And look at the amount of code you had to write in the 60s to put someone on the moon. In the 1990s, we brought the internet. It became a thing. Browsers sent a request to a web server. The server ran a script. It queried the database. It generated an HTML page and then sent it back. Then it forgot everything. You went to another web page. It did the same thing. Each request was completely independent. By the 2000s, we consolidated everything in monolithic applications. Today, we have microservices, which are small independent services that handle one job. They communicate through APIs or message queues. And we went from everything in one place to everything in one application to everything distributed across many services. That was the evolution. But we didn't stop at the backend. As browsers became more and more powerful and could handle more logic and state, we started moving complexity around to the front end. We built rich single-page applications, and we asked ourselves, if we split the backend into microservices, why keep the front end as one monolithic application? Now, over 80 years of coding, two main factors have driven big architecture changes. The first is obvious. New tech appears. We created the internet. We created much more increase in CPU power. We have the browser that evolved in what it is today. Cloud infrastructure. We're now living the AI revolution. We see what's happening with AI. And the second is scale. More and more people are using what we are building. And because of AI and technology, we are building faster and more things than ever, which in turn led to engineers evolving into specialized roles. You have like security engineers, DevOps engineers, backend engineers, and of course, front-end engineers. And as front-end engineers, we need to solve complex problems. With increasing complexity being pushed to the client, we started having the same issues our backend counterparts had in the 2015s. So we took a peek in their backyard, saw how nice and kept the grass looked, and decided, hey, we want to do the same. Now, personally, I was not a big fan of micro-frontends or micro-services in general, because I worked in companies where I had to do big migrations from monolith to microservices, and I saw the problems that microservices had. For example, it was hard to do observability in microservices, and they had amazing tools already built for the backend infrastructure. You had Docker, you had PubSub, Terraform, Kubernetes, entire infrastructure platforms like AWS, Google Cloud to hold their hand, and it was still hard and messy to build microservices. So I said it was hard to achieve observability, it was hard to keep the microservices as micro. Someone added more code, and it was hard to know when the boundaries of the microservice gets breached. And then you just created a distributed monolith, which had all the problems of the monolith and the problems of the microservices. And when microfrontends first emerged in the ecosystem around 2016, almost everyone was using iframes to work with microfrontends. And I've worked with iframes before, and honestly, they suck. I don't want to write iframe syntax every day. They're very hard to debug. So if you open the developer tools and inspect element, you have to check iframe inside of an iframe inside of an iframe. Then if you want to cut, you had the model inside of the iframe, it cut all the content at the iframe corner. You know, and nothing can appear above the iframe. So I said, no, thank you. I was a really big disbeliever in 2016 of the micro-frontend movement. But just because I don't believe in it doesn't mean that it wasn't happening all around us. So at the same time, in 2017, 2018, while micro-frontends were getting popular, another insane theory started to come out. And the beautiful birds that I mentioned in the beginning, well, they aren't real. None of them. All birds are fake. In reality, birds have gone extinct, and what we see in the cities are actually drones by the government to spy on people. Think about it. Have you ever seen a baby pigeon? So I started thinking, if birds are real and tech has evolved so far as to impersonate 11,000 species of birds just to be used as surveillance, then maybe we should give microfrontends a chance. So last year I started a podcast called Seniors at Scale, Seniors and Senior, a little joke there, where I talk with senior engineers, staff and principal level engineers, book authors, library creators, and industry leaders. People like Igor Minar, who is the co-author of Angular, and now he created his own microfrontend framework called Web Fragments. Daishi Kato, creator of ZooStand, Luca Mezzalira, principal at AWS. He wrote a couple of books on microfrontends, and 20 other guests from big companies that I've talked to. And feel free to check and subscribe to the YouTube channel if you want to check it out. But I noticed something that kept coming up in my podcast discussions. In almost everyone that I talk to at these big companies that have over 50, 60, 100, 200 engineers, almost every one of those companies had implemented microfrontends in one way or another. And when the episode with Igor came out, it became my best viewed episode. It had over 2,000 views. And I knew I was up to something. People really cared about the microfrontend ecosystem. So I started asking more and more questions. And I realized that all of these companies, they implemented microfrontends because all of them had one big pain point that all of them had in common, and decided, okay, because of this, we'll invest in this technology. And that was that they needed each team to deploy their work independently. That's it. Of course, there are other benefits and reasons to consider microfrontends, but this was the biggest pain point the last 5-6 years in getting engineering organizations to invest in this. And I felt it too. I had a small startup. We were just 10 engineers who were mostly doing full stack, React and Go in backend. And at least once a month, there were CI/CD pipeline issues. There were changes in a code that affected other parts of the app. Or we were just plain stuck not being able to deploy because there was something wrong with master. So this got me thinking, maybe, just maybe, birds aren't actually real. Maybe the reason you see birds perched at power lines is because they are charging themselves. That makes sense. Power lines have power, it's filled with electricity, and yes, these pigeons are staying out there minding their own business. I'm telling you, birds aren't real. And let's discuss some of the problems that microfrontends solve, and maybe some problems that they will cause. So if you have any of these problems, microfrontends might be the solution for you. So we already mentioned number one, which is the need for each team to deploy independently. If someone blocks the pipeline, you don't want 40 other teams on unrelated features to be blocked. If someone has to revert, you don't want to revert the entire project. If your marketing team wants to deploy 5 times a day, but your payment team wants to deploy once a month, you don't want to force them to deploy on the same cadence. And of course, you have globally distributed teams. You have companies spread around the world, and you have geographic distribution. So if you have teams in different time zones and you have a PR, you can't wait 24 hours for someone to wake up and review your code and then another 24 hours to merge it. You want everything to happen locally and, of course, to deploy independently. And the number 2 problem that we have is legacy systems. Imagine you build an e-commerce platform in 2010. It is highly successful, used by millions of people, but it's built in Angular 1. Which means it's impossible to hire Angular 1 developers today. There are no upgrade options. Angular 1 is deprecated. It's no longer maintained. But your app is used at scale. And you have complex features end-to-end that make rewrites impossible. So you start piece by piece. You rewrite the checkout inside of a micro-frontend and then deploy it in the Angular 1 application. You rewrite the cart in a micro-frontend and deploy it in the Angular 1 application. You write your blog in Next or whatever and put it in the Angular 1 application. So bit by bit, until your Angular 1 framework is just a shell that ties everything together, then you can kill it and replace it with a framework-agnostic JavaScript, and that's it. Now, normally this takes years to do correctly, but I've seen it done and heard success stories about the exact pattern. Another problem when micro-frontends are a solution is when you're acquiring other companies and third-party integrations. If you acquire another company and need to integrate their product inside of your app, you don't want to spend 18 months to 2 years rewriting the entire app to match your tech stack. So if you need to embed a vendor's widget or a punter's functionality, you just fork their code and inject it inside of your app as a micro-frontend. Micro-frontends lets you wrap their existing application and mount it directly in your platform without actually touching their code. Finally, you might have different performance needs. If your home page needs to be a static, SEO-optimized, lightning-fast page that loads in 200 milliseconds, but then you have a login and an internal dashboard that has all these charts and crazy things that take up 40, 50 mega. You don't want the person coming on the homepage to have to download your bundle or the entire project when they first come. Now, frameworks today handle this with lazy loading, but at the time in 2017, that was not possible. And now, after seeing all these problems, I think everyone here is having the same question. And that's, what about bird poop? If birds aren't real, how do we see bird poop on the street? It's literally everywhere, on cars, sidewalks, tables. They leave it on the ground. They poop on people. So think about it. How convenient is that it's everywhere? Especially on people and cars. So convenient that the government can actually use it to track moving objects. But don't be fooled. Micro-frontends have their own problems. So you need to have a consistent and powerful way to handle routing. You need to be careful to maintain UI consistency. You don't want inside of your app one micro-frontend to look one way and another way. You need a powerful tool to observe the system and make sure errors are correctly propagated. You need to share state, which is a big problem. And many more issues, but let's imagine we have some of them solved. Let's say you have identified that you need micro-frontends in your current project. So you're starting a new project and expect to reach the level that micro-frontends solve. So first, if you don't have the infrastructure already built and tested, I don't recommend starting with the architecture at the beginning of a new project, a greenfield project. Micro-frontends and their cousins, microservices, are actually more successful when you break them out of a monolithic application because of the need. Again, the main problem is the number of people and allowing them to build, scale, and deploy independently. If you have one team working on a project of 4 or 5 people, micro-frontends from scratch is probably overkill. It will just slow you down. You create too much boilerplate code, create frustration, and until the infrastructure is done right, you're just going to create multiple monolithic applications, and again, you're going to have the problems of both worlds. So start normal, break out when the system is stable, features are set in stone, teams need to be hired, and domains are clear. Then the question remains, how do we split the microfrontends, and where do we draw the lines between domains? Now, in domain-driven design, we have this concept called boundary context. A bounded context is basically a clear boundary around a specific business domain where certain terms, rules, and logic apply. And everyone uses the same terminology. So, for example, in an e-commerce application, product means very different to the catalog team than it does to the cart team. The catalog team cares about description, images, categories, stuff like that, while the cart team cares about quantity, price, availability. Same word, but completely different concerns. So the trick is to identify these natural boundaries in your application and split your micro-frontends accordingly. You don't want to split by technology or by UI components. You split by business domains. So you might have a product catalog micro-frontend, a shopping cart micro-frontend, checkout micro-frontend. So how do you identify them? Now, in 1967, Melvin Conway introduced Conway's Law, which basically says that the architecture of your software will reflect the social boundaries and communication patterns of the organization building it. So if you cannot fight how the organization is built, you have to work with it. So if you're building micro-frontends, you need to organize your teams and around the boundaries you want inside of your code. If you want the product catalog micro-frontend separate from the checkout micro-frontend, your organization needs to reflect that. You can have one team working on both and expect a clear separation. If you have a team working on both micro-frontends, they will blurry the lines and couple those together and again create a monolithic distributed system. So Luca Mezzalira, when he was principal architect at DAZN, DAZN is, or I don't know how to spell it, D-A-Z-N, it's like a Netflix app for sports. And he devised a clear way to separate micro-frontends. He followed the user's journey. So he saw that during a typical day, he would have like 100 people, not 100,000 people come to the homepage, then 40% will just drop. Then from the 60% remaining, they would go to the sign-in, sign-up journey, and from there, 10%, 20% will sign up and go to the catalog where they see all the events that are happening in that day. And only 5% will actually watch something. So he separated micro-frontends into a landing page, the onboarding experience with the sign-in, sign-up, the catalog experience, which had the entire catalog of the products, FAQ and help, and my account. And when he did this, DAZN was deployed to web, of course, but also to TVs. So it helped a lot to have this micro-frontends. Otherwise, every time someone would open the app on the TV, they had to load the entire project, and it was taking forever. So this approach mirrored how users actually move through the application, and it was reflected in the Google Analytics data. And it aligned very well with how the backend have their domain design principles used in the backend. So by doing this, he realized there are actually two architectures for micro-frontends. You had the vertical micro-frontend, like he did, that follows the user's journey, where each route is its own micro-frontend. Or you have the horizontal micro-frontend, where on the same page, you can have multiple micro-frontends, like a dashboard, where each part of the dashboard is its own micro-frontend. Now, each pattern has its own use cases, strengths, and problems. The vertical micro-frontend is the easiest to build and the most familiar to developers who have built SPAs before. So, like Luca did, he split his micro-frontends by user journey. Now, typically in software as a service app, you know, like a Datadog or New Relic, each menu item on the left or on the top represents a route that opens and loads one micro-frontend when clicked. When your app is structured this way and your organization is structured this way, it's normal to first lazy load each menu item and module inside of your app. And then for even more autonomy, you can even break the routing and put it on the backend. So the backend sends you all the links that you need to render, and on each link where the URL takes. And inside of the Cloudflare or at that infrastructure level, the infrastructure loads that microfrontend for you. And it can be in the same repo, multiple repos, it doesn't matter. But what needs to happen to make vertical microfrontends work, you need to keep the shell application. The shell is what we call the app that loads the other microfrontends, as simple as framework agnostic as possible. If possible, it should just be an empty HTML page with only basic logic for cookie and session management, and it passes down or left the tokens for authentication. Now, normally, in a huge organization, the client platform infrastructure or platform teams would own the shell application to make sure that it's as restrictive as possible. So why is that? One of the technical complexities of microfrontends is sharing state between microfrontends. And it will be a big mistake for every team to manage global state in the application shell. In the vertical architecture, the main routing is decided in the shell, but only the first level that loads a microfrontend. So if you have /orders, /products, this is handled inside of the shell. But once you go to /orders and you go deeper, the next URL structure is handled by the microfrontend. And instead of having the router, again, you can move everything inside of the cloud and handle routing at the load balancer level, where if you go to a URL, the nginx knows which microfrontend to load, and it generates the needed boilerplate to handle this, like header, footer, and the navigation. Again, this is the easiest way to build microfrontends and the recommended way to start once your teams and products have begun to scale. Another way is the horizontal. Basically, this means that inside of a page, there can be multiple microfrontends owned by multiple teams. So here we have the header, who's owned by team C, product details owned by team A, the carousel by B, footer again by C. And there are a couple of complexities that appear with these types of microfrontends. Routing is a little more complicated, so it is recommended to not have second-level routes. If you need second-level routes, again, you go to the vertical way and have only one microfrontend. Most of these microfrontends on the same page need to communicate with each other, so you need to handle communication. There is a bigger need to share state between them. And the boundaries between microfrontends are harder to define. And of course, it's always easy to over-engineer and create a microfrontend when it's not necessary, and you could have just used an NPM library or a web component. And a bigger investment in infrastructure is needed to make this type of architecture happen. And one problem that can be is like one microfrontend is using React 15, another microfrontend is using React 17, and you don't want the client to have to load both React libraries, or Angular and React and whatever. Now, luckily, there are a couple of frameworks out there to help you with this. I think the most popular one right now is Module Federation, but you also have single SPA, Piral, web fragments, Zephyr Cloud as well. And these help manage all of those problems like communication, loading and offloading microfrontends, dependency management. And you can see how each of these stack up in part of my podcast where I talked with some of the authors. And the big advantage is, of course, their reusability and plug-and-play functionality that these frameworks provide. Now, given all of this, let me show you a quick demo, if I can open. Let's see. See nothing. Come on. Yeah. Well, this doesn't work. Well, now I broke it. Okay, no demo. It's harder, but I'm going to explain what should happen. So in a micro frontend with module federation project, you would have a shell and each folder for each micro frontend. Now you don't have to have a monorepo. Each micro frontend can be in a separate GitHub repo, but the shell is where you declare in a web app config where each micro frontend is. For me, locally, that would be localhost /3001. I have one micro frontend. Localhost 3002, I have another micro frontend. I am going to share, but it won't work. So you have all of these micro frontends at different URLs, and Webpack would just load each and every one of them, and it will handle everything like this for you. So you who own a team of a micro frontend, you don't have to worry about the other part of the app. One problem where I was talking to someone at Datadog is they have a huge monorepo with millions and millions of lines of code, and just running lint on the entire project takes them 6 minutes. Booting up the entire project took them 40 minutes. CI/CD, like if you push something to code, it took them hours. So they had to break every route outside of the monorepo, so they had everything localized. So imagine now that you have thousands of engineers maintaining birds that are not real. You want someone to handle the flight, observability, communication, blah, blah, blah. And you might need, if you're on this big birds aren't real project, a marketing team that won't let the truth come out, making sure there are fake videos of birds and stuff like that. So now we know how to split our birds into micro frontends. Let's do some tips and tricks for maintaining them. The first and most important part is what I mentioned, keeping the shell framework as agnostic and as simple as possible, usually owned by the infrastructure team. A typical anti-pattern would be to change the shell project often. Even the menu items and loading or unloading the microfrontends should typically be backend driven. The shell should just call an endpoint, receive a list of navigation and URLs, and then just render them on the page. Another anti-pattern would be keeping global state in the shell. Each micro-frontend should have its own state. Imagine every time you need to add a new attribute or endpoint, you had to change the shell. Then every team will do this, and then the boundary context will blur, and maintaining micro-frontends will in turn turn very complex. So each micro-frontend should have its own state and communicate with other micro-frontends, either by using the backend as a bridge, or having like a backend for front-end gateway, or by implementing a common communication channel. The easiest way to share state is to use query params in the URL. Of course, the URL, every micro-frontend has access to the URL and to cookies. But this would be reserved for very simple and critical states, such as like a user token that needs to be passed. Another way to achieve this is by using the broadcasting API. If you don't know, in Chrome, you can, and Chromium type, you have the broadcasting API that you can communicate between tabs. This could also be used for micro-frontends to communicate with each other. But the most common way to communicate between micro-frontends is by emitting events. With each micro-frontend listening to the events, it is interesting. You can take it even a step further and create like a brain micro-frontend that facilitates communication, allowing you to register events and subscriptions. Now, to solve UI issues, a component library and a design system is almost mandatory. You typically extract this in an NPM package and install it in each micro-frontend. And of course, with module federation, you can handle dependency management quite easily. Then you have to make sure that the CSS is encapsulated, either using Shadow DOM, a CSS module, or an atomic CSS library like Tailwind, to avoid CSS duplication and prevent the client from downloading 20 mega of code just for your CSS. Now, micro-frontends also allow you to go wild. Each team can choose their own tech stack. And I've seen this as, wow, let's do this. This is why we should choose micro-frontends, because we can choose our tech stack. But honestly, I don't really recommend this approach. It's actually a slippery slope towards, again, distributed monolithic application, which we want to avoid. Plus, it adds extra complexity for the infrastructure team who have to maintain different pipelines for each front-end framework that you have to import in the app. And then the client also has to pay a price because it needs to download a lot of vendor plugins for just to render a page. And I will also take advantage of really big, powerful frameworks right now like Next.js, Astro, Nuxt. They have become super performant and can make integrating micro-frontends inside of a monorepo project really quite easy. So try to keep it simple. Root at the client level so you don't see page refresh every time you click on a link. When you do micro-frontends at an infrastructure level with Nginx, this is the one problem that once you click a link, you kind of see a refresh. The user sees a refresh. Yeah, you just need to keep the root at the client level. Use React query or TanStack query, and you can reuse the same keys within different micro-frontends. Follow DDD practices and avoid falling into the everything should be a micro-frontend pattern. If your team is responsible for specific domains and KPIs, you should own at most 1 or 2 micro-frontends at most inside of your team. Now, if you're thinking of building horizontal micro-frontends, again, try going vertical first, split the roots into micro-frontends, and then when that worked, go inside that one micro-frontend and make it multiple. And if your main reason for creating a micro-frontend is reusability, then maybe you don't need a micro-frontend, maybe you need an NPM library, maybe you need a web component to make it work. And the last one goes without saying, but if you have like 4, 5, 6 developers in the team, the micro-frontend is not the solution that you need. Now, the most important part of this talk and the message I want to send is to focus on pain. See which part of your software is causing pain and whether you need your own research and on how to solve it. Just because someone is staying on stage and saying that birds aren't real, don't listen to him. Like, check what works for you. Everyone has a different context and works in a different product. And I really, really like the birds aren't real conspiracy theory. It is a real conspiracy theory. It was created in 2021 as a joke, but people took it for serious, and now there are conventions around it, and there are a lot of this movement that has 100,000 follows on Facebook, and it's really, really popular. Even the creator who created it as a joke had to come out and say that, hey, it's a joke, it's a joke, it's a joke. But no, people take it for serious. Now, going into a micro-frontend architecture is also a one-door decision. Once you take it, it's very hard to switch back. And choosing a micro-frontend framework also creates significant vendor lock-in. If you've chosen module federation, you're stuck with it. And it does have its own technical challenges. So make sure you're choosing very, very carefully. Here are some resources that I highly recommend. We have Building Microfrontends by Luca Mezzalira, The Art of Microfrontends by Florian Rappel, Learning Domain-Driven Design by Vlad Konanov. I also have 3 or 4 episodes on my podcast just about microfrontends. And I have a lot of discussions, and on LinkedIn I talk every few days about microfrontends. If you're interested, I also host a workshop, remote and in Barcelona, if someone is from Barcelona, from lizard to wizard, and we talk about system design, design patterns, observability, how to build your own microfrontend if needed. And yes, I also have a free security course for front-end developers. There are 2 modules that are out right now talking about cross-site scripting, talk about exploits, vulnerabilities, and how AI prompt injection, document poisoning, CI/CD poisoning. It's insane what's happening these days. So if you're curious about security in front-end application, check out this course. It's completely free, and it's always going to be free. And yeah, finally, I have a weekly newsletter where I share articles, conference discounts, podcast takeaways, and some of the top articles in the JavaScript ecosystem right now. So given that, hope everything in this talk helps you in the future to make smarter decisions and to stay vigilant. You don't know where the birds are watching and pooping. So thank you.